So first we're going to have the instruction called evaluate. So your question first is you see a radical sign, like a root, and a negative underneath. So your first thought should be, can I do this? Or is it just undefined? So can we do the cube root of a negative? The answer is yes. So now there is a fraction here, so we can actually split this up to be the cube root of negative 27 over the cube root of 64. So 27, three numbers, the same three numbers that multiply to give 27, negative 27. Has to be negative 3. 3 times 3 times 3. So this will be negative 3. A 64. It is 4. You could double check, but it is 4. And that would be it. Now, my second question looks like this. So let's say the fifth root of 1 over minus 1 over 32. And I put the minus, I had to squish it in because I meant to put it in front of the fraction. Do you see the little minus sign there? Yeah. Is this any different than putting the minus sign on top like in the first one? No. It doesn't apply to both the top and bottom. It is just in front. This one is also the same. When you put a negative 1 over 32 or negative 1 over 32 or 1 over negative 32, they're all the same thing. It's one negative sign for that fraction. Okay? So sometimes when books type, they'll put it in front. I often put it on top when I'm writing by hand, but then when I'm typing, I'll just stick it in front of the whole fraction. But it makes the whole fraction negative. Doesn't matter where the negative sign, that's a negative. The thought is sometimes people think that that applies to both the top and the bottom, and that's not true. That would be a positive. Okay, so this is not equal. So you don't put them negative on top and bottom, because then when you divide a negative number by a negative number, you get a positive number, so that's not true.
Why is only the 27 negative?
You could put it with the top, the bottom, it doesn't matter, or in front. So that's what I'm saying. It isn't the 27 necessarily that's negative. You could put it with the 64. You would still end up with the same answer. You'd have a 3 over minus 4, which is the same thing. It doesn't matter if you put the minus on top, bottom, or in front of a fraction. It's still just a negative. Okay, so for example here, where this was in front, I get to choose. Do I want to put it with the top, the bottom? It doesn't matter. So I can say this, usually you put it with the top, but it doesn't really matter. It's just more a standard practice than an actual rule. So when you break it up, it would be that way. Now, can we do a fifth root of a negative? Yeah, any odd one will work, because when it's even, a negative and a negative match up, and that would be a positive. So a fourth root wouldn't work with a negative, a sixth root wouldn't work with a negative, because they'll all match up. But whenever it's odd, you have one negative sign left. So it makes it negative. So what about negative 1, the fifth root of negative 1? Negative 1. All right. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1. And 32? 2. So negative 1 over 2. You put the negative on top, bottom, or in front. Doesn't matter. They're all the same thing. Okay, what if we end up with something like this? That's called a nested root, or a nested radical. Means it's inside the other one. So what would we do first? Yeah, the inside one, which would be square root of 16, is what? 4. So you just rewrite it. Instead of the root 16, we would have a 4. And now how do we evaluate that? Same as we're doing up above. You take the square root of the top, square root of the bottom. Square root of 1, square root of 4. Square root of 1 is 1, square root of 4 is 2. Okay, what about this one? So this one, the negative's in front. It's just like -1 times whatever you get as your answer. Okay, that negative doesn't actually apply to anything except being multiplied in front. So our answer is going to be negative, and then whatever we get as our answer here. Cube root of 64. No. So 64, let's write the roots. So 64, what two numbers multiply to 64? Any two. 8 and 8? It's okay, it's early. This is 4 and 2. So 4 times 2 times 4 times 2 equals 64. And could we go further down? All right. So let's count up how many 2's there are. So 6 2's. So 64 is 2 to the power 6. Oh, which is 4. Did I say no to 4? Yeah, okay. Well, that's all right.
It's early.
It's early. I said it was okay for you guys not knowing 8 times 8, but I actually messed up. But that's fine. I was actually trying to get one that didn't work when I wrote it. So that's what I had in my head, one that didn't work. That's okay. So it does work. Okay, so let's go with it this way. Say you didn't know it was 4. Okay, so say you did this, you wrote the factors to try to see. So this is what I was trying to get at. If we were doing the cube root of 64, okay, so let's just write them both out. So remember what the cube root is as an exponent is what? 1/3. So we could say this is negative 2 to the 6 is 64, all to the 1/3. 2 times 1/3, or 6 times 1/3, 2. I'm just leaving space for the bottom here. So 2, 6 over 3, which is 2. What about 125? Five? 5 times 5 is 25. 25 times 5 is $1.25. I think in quarters. So 5 cubed. This is 25 times 5. And if you think of 5 quarters, that's $1.25. So 125 is 5 cubed. So the cube root of 125 is 5. Or you could do it the same way. Like if we said this is 5 cubed to the 1/3. This would be 5 to the 3 over 3. All right, so 2 to the 2 over 5 to the 1. Okay, so just if we had something a little different, and these could be substituted with like an x. X to the 6 over 3 would be x squared, that kind of thing. Now the minus, I put it on top. It was in front of the whole thing, but again, a minus in front of the fraction, whether you put it on top in front or on bottom, is all the same thing. Okay, it doesn't matter where it is. Okay, so let's add a little layer to this. So let's say the directions say simplify. So if I was typing that, I'd probably put a little dot in between. They're all x's, and they all have exponents. And what's the rules of exponents? When you have the base the same, you would add the exponents. So if we get what the exponents all are here, for these x's, we can add the exponents. It doesn't matter if there's 2 or 3 or 5, you would just add all of the exponents. So the first one is x to the 1. What's the second one? X to the cube root would be 1/3, and a square root 1/2. And again, just like I said in the last time we were doing these, is leave the outside until you finish simplifying inside. It makes it less things to apply that 3 to. Okay, so we're going to add these exponents. So what do we need to add? 1 plus 1/3 plus 1/2. So we need to do a common denominator. So this is like a 1 over 1. The common denominator would be 6. So 6 over 6 plus, multiply this one by 2. So 2 over 6, multiply this one by 3. 3 over 6. So we have 6 plus 2 plus 3 all over 6. 6, 11. So we've got, and I just did that off to the side, x to the 11 over 6 cubed. And now how do we deal with that? Multiply the exponents. So we would multiply, that was the adding of the exponents. And then if we were to multiply the exponents, multiplying 11 over 6 times 3, and that would be a 3 over 1. It could be 33 over 6, but does anything simplify? 6 is 3 times 2, right? So we could say this is 11 times 3 over 3 times 2, and the 3's cancel. So what do we have left? 11 over 2. So this is x to the 11 over 2, and that would be your answer. Could we write that again as a radical if we wanted to? Sure. The 2 on the bottom means square root, and the 11 on top means the power. So this, if we wanted to, would be the square root of x to the 11. Like that. Questions? So far, so good? All right, let's add a fraction into it. Oops, that's a y. Okay, this is a crazy one. Okay, everyone have it written down? What would be a good first step? Or any first step? What could we do? Well, all those root signs make it look kind of confusing, right? So what if instead of all those radical signs we made them as exponents? Even if they were fractions, we don't like fractions, adding and multiplying fractions, but you probably will have to do that eventually in this question. So what about making them all x's and y's all with exponents instead? It would look a little neater, and then we would be able to see which ones we need to add together and things like that. Does that make sense? Okay, so let's carefully do that. You could approach this by just keep writing it down, the whole top, the whole bottom, which is what I'm going to do. The other option would be just to take the inside of that top bracket, put it off to the side, simplify it, do the same with the bottom off to the side, and then put them both back in with the squared and the fifth. That would be the other option. But they're both quite big, so I'm just going to just write them all as I go down. All right, so what's the power on this first one? It's an x, and it's a cube root squared. So 2 over 3. So x to the 2 over 3. Now the next one, this is the square root, and they apply to both of these. So that x would be to what power? 3 over 2, because a square root's understood to be a 2, so this would be 3 over 2. And the y? 7 over 2. The next x? 1 over 3, because that's just an x to the 1, and that's a third, so 1 over 3. And the y? 5 over 3. Now that's all still squared, but again, we're ignoring that until we get the inside worked out nice. Okay, so you just keep writing that outside. Let's do the same thing on the bottom. The first x is a square root, and that's x to the 1, so that would just be x to the half. Y, square root of y squared. Just be y. Right, the square root of y squared is just y, because that's y to the 2 times 1/2, which is y to the 1. So that's just y. The next x, it's a cube root and squared, so 2 over 3. Y, 4 over 3. And the last one, x, 1 over 5. 1 over 5, and that's all to the 5th power. Okay, now what? Add what exponents? Which ones do we add together? All the x's, so there's 3 x's. They would all go together, and then the 2 y's would go together, because you have to have the same base to be able to add the exponents. So I'm going to do an extra step that you don't need to do. I'm just going to move them. You can write it if you want to. And I'm just going to rearrange them so that all the x's are together. And the y's. Okay, sort of an unnecessary step, really, but I want to demonstrate. The x's go with the x's, and you add these exponents. The y's go with the y's. And remember, because they're all being multiplied, we can change them around into whatever order we want. So even if you didn't write this step, or, you know, you might have written it now, because I did, but even if you don't want to write that later, you would look here and say, okay, I need to add 2/3 plus 3 over 2, and there's another x here, so I also need to add that one 1/3. Right? If you rearrange them, you can sort of see them. Now, you have no calculator, and you have to do it by hand, so I would just do it off to the side, find the answer. Instead of trying to do it in your head, that's when mistakes happen. What's the common denominator here? 6. So we're going to multiply the first one by 2, the second one by 3, and the third one by 2. So 4 over 6 plus 9 over 6 plus 2 over 6. 9, 10, 11, 12, 13, 14, 15 over 6. So that's for the x's, these first x's. So x to the 15 over 6. So just one x, and we've added the exponents, so we've condensed them all to 1. Now what about the y's? We've got a 7 over 2 plus a 5 over 3. Again, 6. So 7 times 3, and 5 times 2 is 31 over 6. and that's all squared. Okay, so that's the top, the numerator. The denominator, do the same thing. So our first one is the x's, 1/2 plus 2/3 plus 1/5. What's the common denominator there? Yeah, 30. So this would need to be 15 to get the 2 into a 30. This would need to be 10, and 5 times 6 is 30. So 15 over 30 plus 20 over 30 plus 6 over 30. It's 35/41 over 30. And the y's? So what's this exponent? 1. 1 plus 4 over 3. So that's 3 over 3 plus 4 over 3 is 7 over 3. And that's all to the 5. All right, almost done. Two last steps actually, Bildy. So what would we do next? Exactly. What would you not do next? So she said what you would do next is put that 2 or multiply that by each of these and then do the 5. What would you not do next? So sometimes what we've been doing all along is sort of simplifying top and bottom first before applying the... Why can't we do that in this case, since we've been doing that all along? I didn't hear what you said, but I'm guessing that you maybe said because this is a 2 and that's a 5. They're not the same exponents. So this is not one big fraction that we're simplifying the inside of before we apply the exponent. This is 2 separate brackets with different exponents. So we've already simplified the inside. You can't simplify up and down because they're not together as one fraction all to a power. Okay, so this is 2 separate ones with different exponents. If there was a 2 on the bottom, you could do that, because you could write it as one big fraction all squared, and then simplify the inside. All right, so if that 5 happened to be a 2, you could, as your next step, write it as one big fraction and simplify so you only have one x and one y by subtracting exponents, and then apply the 2. But it's not. These are separate. So that 2 gets multiplied by each of these. So this would be x to the 15 over 6 times 2, and y to the 31 over 6 times 2. And the 5 gets multiplied on the bottom in the same way. A little bit squished there. So 15 over 6 times 2.
Is that 2 just for the top? 30 over 6?
Yeah, because that's like a 2 over 1, right?
30 over 6.
You could do 30 over 6, which is what?
5. 1?
Just 5. Right? If you did 30 over 6, that would be okay. I like to simplify first, but 5. So that was the x on the top. The y, 31 over 6 times 2, and that's like a 2 over 1. Anything cancel here? 6 is 3 times 2. 31 over 3, does that go further? No, 3 doesn't go into 31. 3 goes into 30, but not 31. The x on the bottom, 41 over 30 times 5. Does the 5 cancel? (41 over 6). And the last y is 7 over 3 times 5. Nothing cancels. Okay. So you notice all along, I just kind of do any little calculations. You would say you would normally reach for a calculator. Okay, what's that, a new exponent? You just do that off to the side and then write it back in. If you didn't, you'd have to sort of figure it out and write it in at the same time, and it gets messier looking. And this one's already crazy looking. So you're still not finished. What could we now do? Yeah, subtract the exponents. Or cancel, but we can't just cancel when there's fractions. That's not as easy to see. Like, if we had x cubed over x to the 6, we could see 3 of them cancel, and there'd be 3 left on the bottom. Right, but when they're fractions, it's a little bit harder. We subtract the exponents. So how do we subtract exponents? So the rule was this: x to the top minus the bottom. It's really like you're bringing the bottom up, and it becomes a negative n when you bring it up. So here we would have x to the 5 minus 41 over 6. And y to the 31 over 3 minus 35 over 3. So 5 minus 41 over 6. It's like a 5 over 1. So common denominator 6. So if we multiply that by 6, 30 over 6 minus 41 over 6 is minus 11 over 6. The y's are already set up with a common denominator. 31 over 3 minus 35 over 3 is negative 4 over 3. Now they're both negative. If we wanted to leave our answer with positive, they both have to go to the bottom, which would leave what on top? A 1. And that would be your answer. Crazy full-page question. Harder than you would get on a test or anything, but if you can duplicate that, so you write that question down, and later on you try it, and it's all about being really careful, right? Knowing when to add, when to multiply. If you can, and then if you can't follow, what you would then do is go back to the example and look and say, okay, how many steps are in this particular question? What did you do first? What did you do second? For everything that I did, I kind of had to do it 4 times. For the x's on top, for the y's on top, for the x's on the bottom, for the y's on the bottom. I sort of had to do 4 things. Right? And that's why it ended up being so long. I could have made it shorter, but I think that if you can do a really hard one and get the right answer, and so you do have the right answer here. No one screamed that I made a mistake, so I think we're okay. Then that would be a good question to try. If you can do the harder questions, then when you get on a test, what happens? It seems so easy because the questions are much easier than they were. Okay.